So I wanted to look at the problem from question number 7. I think this is 7.3. It's number 5. It's asking us to find the arc length of the cycloid defined by these two parametric curves. X equals 9 times t minus sine t, and y equals 9 times 1 minus cosine t. All right, and so we look, and I draw a graph of the cycloid because it wants to have only one arch of the, I guess, the first arch of the cycloid. And so we want just this one arch. And so what I'm going to do is I want to find my bounds. And to find my bounds, this is actually the first tricky part here, is I just want to figure out, okay, when y equals 0 to y equals 0. And that's because we need to find t, right? We need to find our t1 and find our t2. So we want to find both of those, okay? And so how we're going to end up doing that is we're going to end up actually going in and we're going to set y equal to 0 and then solve. And so when I do that, I get 0 equals 9 times 1 minus cosine t, and that then gives me that 1 cosine t equals 0. And we'll go from t equals 0 and t equals 2 pi, right? So those are going to be the two bounds that we have for this first cycloid. That's going to be 0 to 2 pi. Okay, so that's one cycloid. Now what we need to do, right, our arc length formula, okay, and I already did it right here, but I'll remind you, the arc length formula is going to be the integral, okay, and in this case, it'll go from a to b times the square root of dx dt squared plus dy dt squared, okay, dt. And so that's what I did. I found the derivative, so I found dx dt, and I found dy dt for our x and our y, respectively. Okay, put those in, they're going to square each one of them, and so there's that. And now, when I go in and I simplify, I end up with this. The integral from 0 to 2 pi times the square root of 81 minus 162 cosine t plus 81 cosine squared t plus 81 sine squared t dt. Okay, so that actually ends up being our integral. And this is actually where a lot of people get stuck. It's where I got stuck for a while. I had to do some reading in order to figure it out. So now we go from that to 0 to 2 pi. We have the square root of 81 plus 81 times cosine squared t plus sine squared t minus 162 cosine t. All right, and again, I think a lot of people got that one. And essentially, this is going to then give me the integral from 0 to 2 pi times the square root of, and this will end up being 162 minus 162 cosine t dt. So what we're going to do in order to actually go through and simplify this is we're actually going to use some trig subs. And this is kind of tricky. And, you know, I don't think I would have initially thought of this initially. So I go in, I've got 0 to 2 pi. And what I'm going to notice is that cosine t, right, is actually cosine of 2 times t over 2. So I can actually use a double angle formula right there. So I'm going to do that, and I'm going to do that in conjunction with, right, thinking of 162 as 162 times cosine squared t over 2 plus sine squared t over 2. All right? So what that's going to do for me is it's going to end up kind of allowing me to have some things cancel out and then simplify. All right? So what I'm going to do now is I'm going to say, okay, well, cosine of 2 times t over 2 is going to equal, nope, that's correct, cosine squared t over 2 minus sine squared t over 2. So I'll replace this, and I'm now going to end up with, and it's going to be a little bit of long writing, I'm going to get 162 times, and I'll have cosine squared t over 2 plus sine squared t over 2, okay? And that's to replace the 1. So this is 162 times 1, so we'll put in the 1 there, okay? Minus 162 times cosine squared t over 2 plus sine squared t over 2, okay, dt. And then that will end up equaling, okay, this integral from 0 to 2 pi, and this is going to be the square root, and we'll deal with the 162 in a minute, is going to be 162, okay? And this will be then 162, the cosine squared t's, they're going, or t over 2's, are going to cancel, right? Because one's negative, one's positive, and so we're just going to end up with 2 of the sine squared t over 2's. So that's times 2 sine squared t over 2 dt. And what that leaves me with is the integral from 0 to 2 pi times the square root of 324 sine squared t over 2 dt. And that now is equal to the integral from 0 to 2 pi of 18 sine t over 2 dt. And we can just go in and integrate that. So this is going to actually equal 18 times, and this will be 2, or negative 2 cosine t over 2, evaluated from 0 to 2 pi. And this will then be 18 times, and this will be negative 2 times cosine of pi minus negative 2 times cosine of 0, which is going to end up equaling 18 times, and this is negative 2 times negative 1, so this is going to be times 2 plus 2, okay, which equals 18 times 4, and that is 72. So it's that substitution, which is a wee bit devious, wee bit tricky. You'd have to kind of think through that substitution there. This one here, okay. But once you do, then it's just a matter of some simplification. Okay, all right. I hope that kind of helps to clarify things. You know, the first tricky part there is to find the bounds, but then once you've done that, then it's just a matter of some substitutions and becoming kind of clever with your substitutions.